Hi, class. So I'm going to look at the last part of percent problems, and these are the word problems. Okay. So in a percent problem, there are three numbers: the percent, and it's going to be with the percent symbol. The part is to the left of is, and the whole is after of. The fundamental percent equation is this: something is AX percent of the whole. Percent of whole equals the part. Part equals percent of the whole. Now, you want to take a few minutes and say this to yourself. The fundamental percent equation is this: something is X percent of the whole. Percent of whole equals the part. Part equals percent of whole. When you're working with a percent problem, you get a percent of the whole. You can't get a percent of the part. You have to get a percent of the whole. So percent of whole equals part. Say that to yourself. Percent of whole equals the part. Part equals percent of the whole. However you want to say it. Percent of whole equals the part. Then you can just turn this around and set up your equation. Percent of whole equals the part. Part equals percent of whole. Okay, so let's take a look at our first word problem, and let's see, make sure you can see this. Okay, all right, so it says Josh started to run on a treadmill after setting its timer for 93 minutes. The display says that he has finished 34% of his run. Okay, 34% of his run. How many minutes have gone by? Round your answer to the nearest tenth. Now remember, there are three numbers: the part, the whole, and the percent. Now once we identify this, then we can set up the equation. Okay, now he set the timer for 93 minutes, so that means that he wanted to run for 93 minutes, so that would be the whole. Now we see the percent here, which is 34%. So that means we're trying to find the part because it says how many minutes had gone by. Okay. Okay. So we know percent of whole equals part. Part equals percent of whole. Okay. So let's see what we have. Percent of whole equals the part. Part equals percent of the whole. We don't know what the part is. So that's X. So X equals 34% of 93. X equals, let's change this to a decimal, move it two places. Of means times 93. So X equals, let's see what that's equal to. That's 3162. And we're told to round to the nearest tenth. Okay. So this is the tenths. We look to the right. It is not 5 or more. So it stays the same. So he ran 31.6 minutes. All right, let's take a look at this one. Okay. It says an item costs $500 before tax, and the sales tax is $20. Okay. So it says find the sales tax rate. Now, this problem is a problem that we know. We know that the sales tax rate, okay, and the sales tax. The sales tax is the part. The sales tax rate is the percent, and that's what we're trying to find. Okay, so we know then that part equals percent of whole. Now, when we're dealing with sales tax, the sales tax has got to be the part. The cost of the item is the whole. So we have $20 is equal to X percent of 500. Okay. So 20 equals, remember we put a 1 in front of that. And then we need to move the decimal 2 places to the left. 1, 2. All right, and then we want to multiply the 0.01 times 500 and put the X on the end. And so that's going to be 5X. And so we say 20 equals 5X divided by 5. 4 equals X. So that's 4%. Okay. Now, remember, you can also set this up as a proportion. It just depends on what you like. Okay. So if we set this up as a proportion, we would have X over 100 equals 20 over 500. 500X equals 2,000. Okay. Divide by 500. And we get 20 over 5, which is 4%. All right, let's take a look at this one. All right, it says a chemist is using 354 milliliters of a solution of acid and water. If 13.7% of the solution is acid, how many milliliters of acid are there? Okay, now we have this solution of acid and water, and that's 354 milliliters. So that's the whole. Now we got 13.7% is the percent. So we're trying to find the part, and we don't know. But we do know that percent of whole equals the part, or you can set this up using a proportion. Okay. All right, I'll set this one up using a proportion. So we know that percent over 100 equals part over whole. So the percent is 13.7. Now, just a reminder, when I put this over 100, I don't move into decimals. When I use the proportion method, you don't move into decimals because, see, you're putting it over 100. That takes care of it. And then the part we don't know, and the whole is 354. So 13.7 times 354 equals 100 times X. So let's see what that is. So this is 4849.8 equals 100X divided by 100. And so we get 48498 equals X. And it says to round to the nearest 10th. So 48.498. This is the tenths. We look to the right, that's 5 or more, so we get 48.5 milliliters. All right, let's take a look at this one. It says an international company has 16,900 employees in one country. If this, you see this often in percent word problem. If this represents, that's the same thing as saying if this is, represents mean is. If this is 27% of the employees, this is good stuff here. So 16,900 is 26.9% of the employees, and I'm going to use an E. Okay, so we can set this up. We can use a proportion. We can use an equation. I used a proportion last time. Let's use an equation this time. So 16,900 equals, change this to a decimal, 0.269, and that'll be a capital E. And we solve this, divide by 269. Let me get my calculator. Now, you know we can't have a fraction of an employee. So we get 62825.27 equals E. And so we just round this to the whole. 2,825 employees. This is the same type. An international company has 19,000 employees. This is 31% of the employees. Same type. Represents okay. Right. And we'll set this up as a proportion. And the part over the whole. All right, so we cross multiply. 31.8 E equals 19.3, add 2 zeros, okay? And then we divide by 31.8. So E equals so we have 60691.82, 60,691. Okay. Round to the nearest whole, so that would be 92. Now, why is it 692? Because this is the whole, and that's 5 or more. Okay. All right, let's take a look at this one. All right, sales tax for an item was $10.50. It cost $3.50 before tax. Find the sales tax rate and write it as a percentage. We know that sales tax is equal to sales tax rate times the cost. So the sales tax was what, $10.50? And the sales tax rate, X percent of the cost. So 1050 equals, now anytime our variable is a percent, we need to put a 1 here. And then we move the decimal 2 places to the left. 1, 2. And we have 0.01, 350, and X. And so we have 1050 equals 3.5x. So we're going to divide by 3.5. And let's see what that gives us. So this is 3%. Okay. All right, let's see what this is. An item is regularly priced at $76. It is now priced at a discount of 10% off the regular price. Find the new price. Now, all of us know how to do this. 10% off, and we would just say 76 times 10%, change 10% to a decimal, and we get $7.60. Okay. And then we would say 76 subtract 760. So we get $68.40. So there's no point in making this difficult. Okay. All right. The last thing we want to look at is percent of increase and decrease. Okay. So the percent of increase or decrease is equal to how much is the increase or how much is the decrease over the original amount. Now to find out the increase or decrease, you're going to subtract original minus ending. If it ends up to be a negative on top, that means it was a decrease. Okay. So the original amount minus the ending amount over the original. Okay. And then we're going to take that fraction and change it to a percent. Now, to change a fraction to a percent, remember we multiply by 100 or we just change it to a decimal. Okay. So this is original minus the ending. So let me keep this up for us to see. All right. So the price of an item dropped to $99 today. Yesterday it was $180. Okay. Now the original amount, okay, the price of an item has dropped to $99 today. Yesterday it was $80. Okay. So we have what? The original amount was 180 and now it is $99 over the original amount, which was 180. So let's stop. The price of an item has dropped to $99 today. So this is ending. All right. Yesterday it was 180. This was the original. Okay. Because yesterday came before today. So the original amount was 80 minus the ending amount, which is 99. And then this was the original. So 180 minus 99 is what? 1 and 8. Let me make sure. Over 180. Okay. So 81 over 180. And we're going to change this. Okay. Now, when I do this on my calculator, or you can change this to, well, let's do it. All right, so this is a fraction. Now to change a fraction to a percent, I can multiply by 100. I do that. And I can look along these diagonals. I see these end in 0. And I also see that they're even. So I divide 10 into each one, and I can divide 2. So I can divide 20 into 100 and get 5. 20 into 180, I get 9. So 81 times 5 is what? 405 over 9. Okay. And let's see what we get. So 9 to go into 40, what? 3 times? Not 3, 4 times. 4 times 9 is 36. Subtract 4, 5. So 45% is a 45% decrease from the original. Okay, so let's see if that's correct. So let's take 45% of 180. Okay. Wait a minute. So I get $81. So I say 180 minus 81 equals 99. So that is correct. All right, let's look at this one. The price of an item has been reduced by 40%. The original price, $31, okay? And it's been reduced by 40%. So this is just like the other one. We would just say 31 times 0.40. And we get $12.40. And so we would say 31 minus 12.40. And so that's going to be 60. So that's going to be what, 18? Let me double check. So 10, yeah. So 1860. Now, when we are actually teaching business classes, we do this. Anytime you have discounts, so it's reduced 40%, okay? So they're taking that off. So that means you pay 60%. Now, where did I get 60%? 100% minus 40% equals 60%. So since you're going to pay 60%, we say 60% times 31 equals what you pay. So this is 0.60 times 31. All right, so 31 and 60, 0, 6, 18, 1860. So when we actually teach in business classes, we're trying to cut out some of the steps. So instead of taking the discount and then subtracting, we just say, all right, if we're knocking off 40, you're going to pay 60, and then this is what you end up paying. Now, when you do it like this, then this problem, you don't have anything to worry about. Students often get multiple discounts wrong. So you get 25% off, then you take another 15%, and then you take another 10%, okay? So students actually think that you're getting 50% off, but you're not. So what you're supposed to do, because you have a series of discounts, all right, they're knocking off 25, you're paying 75. They're knocking off 15, you're paying 85. They're knocking off 10, so you're going to pay 90. So then we change these to decimals and we multiply. Okay, so you're going to pay 57.375%. Clearly, that's not 50%. It's close, but it's not 50%. Okay, so let's see what it is. All right, so you pay 57.375%. If we subtract this from 100, so actually your discount is 42.625%, not 50%. Okay. So that's a way that you can find out what your actual discount is. Now, this is one that I love. So you take 50% off and then take another 50% off. So you should get this free, but they're not going to give it to you free. So if you take 50% off, you're going to pay 50%. Take another 50%, you're going to pay 50%. So this gives you 0.025. So you pay 25%, and the discount is 75% because 100 minus 25 is 75%. So your discount is 75%. It's good, but they're not giving it to you free. All right, let's take a look at this. A house on the market was valued at $268,000. After several years, it decreased by 7%. By how much did the house value decrease? What is the current value? So it decreased by 7%. Now we can do it. If it decreased by 7%, you paid 93%. Okay. Now I'm going to do it two ways. I'm going to take 7% of this. So 7% of that is $18,760. Okay. And so 268 minus 18,760. So it decreased by that amount. So now it's valued at 249,240. Okay. So we could have said 268 times 0.93. And we would get 249,240. So there are different ways that you can look at these problems. All right, let's take a look at this one. It says, Ivan opened an investment account was $5,800 at the end of the year. The amount in the account had increased by 22.5%. How much is this increase in dollars? How much money was in his account at the end of the year? Okay, so this is a problem that we know how to do. The account increased by 22.5%. So we would say 5,800 times 22.5%. So let's see what that is. So that's pretty good. So this is the increase amount. And so this is 1305. And so he has 7105 in the account. Okay. Now let me talk about this problem again. Okay. And so typically what we do when we're teaching these finance classes like this, and the same thing if you're getting a raise. So if it increased 22.5%, we would say 5,800 times 1 plus 22.5%. Now, what does the 1 represent? The 1 represents the original amount, and then this is how much we have. So it's going to be 5,800 times 1.225. So let's see what we get. So the new amount is 7105. So if you were getting a raise, So let's say that you made 4,600 a month, and you got a raise of 6%. Okay, so to get your new salary in one step, we would say 4,600, 1 plus 6%. 4,600, 1 plus 0.06. So 4,600, 1.06. And that would take care of the original plus the percentage. So that would be 48.76. Okay. All right, so we have completed all of our percent problems, interchanging fractions, decimals, and percents. We looked at ratio and proportions. We looked at numerical percent problems, and we have looked at word problems. So I hope this helps. If you have any questions, just email me, and I'll talk to you later.